The scene: an 11-foot snake slithers among a cache of eggs and a sauropod dinosaur hatchling. But before the snake can grab the hatchling, a landslide, a debris flow, buries the eggs, the hatchling, and the snake. 70 million years later, these rocks are discovered, these fossils are found and described by Wilson and his colleagues in 2010 from this late Cretaceous deposit from India. We're going to take a look at that paper, and this is the latest episode of Flood Geology Failures. This paper includes several different challenges to young Earth creationists or flood geology failures. We got that coming up next. Yeah, here we go. We got another paper in which we're describing a potential behavior or inferring a behavior from the fossil record. But it's not so much the behavior that we're really going to concentrate on here. It's the presence of a snake in a dinosaur nest, the presence of snakes at all in the fossil record and where they're found. And then the very fact that there's so many dinosaur eggs and nests in the fossil record. Those are going to be our three main observations and our three challenges to young Earth creationism, or the young Earth flood geology model of the world being enveloped in a global flood just 4,000 years ago and responsible for the majority of the geological column, including the vast majority of the fossils found therein. All right, let's get right to it. Predation upon hatchling dinosaurs by a new snake from the late Cretaceous in India. I said before, we have Jeffrey Wilson and some colleagues are describing a particular fossil at this particular site. Now, this site actually includes thousands of discovered dinosaur eggs, specifically sauropod eggs. And how do we know that they're sauropods? Well, we have some bones, all right, remnants of the dinosaurs themselves, along with the eggs. But more importantly, because that's a correlation. But more importantly, some of the eggs have bones inside, or there's new hatchlings in the nest that are preserved for us. Those hatchlings clearly are sauropods, all right, connected to the same adult organisms, also with their bones found in the same area. So remember that we've got a collection of things, eggs, youngsters, and adults, all found in the same area. And now we're going to mix in several different snakes, actually multiple individuals of the same species of snake. And so there seems to be some snakes that are predating upon the new hatchlings that are coming out of these nests. And to top it all off, there's even some coprolites at this site. That's dinosaur poop, all right? That's fossilized for us too. So we see a day in the life, or probably years, probably tens of thousands of years of the life of sauropods in this particular area. Because there's multiple nests found on multiple different layers of sediments, suggesting that a sauropod herd comes back to the same site over and over and over again. And as new sediments are laid down, and we see that clearly these sauropod eggs were preserved by a local event, which then covered up the nest, and in this case, providentially preserved a whole snake in one of these nests, making it one of the best preserved snakes that is this old. All right, so let's just get right to the paper and show you a couple pictures, and then we'll talk about the challenge that this data represents. But I want to read a tiny bit of the introduction here. Snakes are limbless reptiles, right? No doubt that snakes are a type of reptile that first appeared in the fossil record in the middle of the Cretaceous, approximately 98 million years ago. Now that's actually outdated. This is 2010. I did a quick look, and now it's suggested that the earliest fossils are somewhere around 130 million years ago. So the early Cretaceous. And even possibly at the end of the Jurassic, there's some questionable fossils, and there's also some other forms of analyses that suggest that snakes have been around a little bit longer than that. But that in itself I was surprised. I think I knew that, but I was really hit again by the fact that there aren't any snakes in the fossil record until you get to the Cretaceous period, right? So the Triassic and the Jurassic, which are full of dinosaurs, all right, and lots of other different reptiles. Okay, there's turtles, and there's all kinds of other things. And actually, turtles are kind of latecomers too, but um, various types of iguanas and other forms of reptiles, right? Got pterosaurs, mosasaurs, right? They're found in abundance in the fossil record, especially in the Jurassic. And then, of course, you have amphibians and so forth found even earlier than that. And yet, snakes, unknown in the fossil record. So that itself is a little bit of a mystery. That is a observation of the appearance, in terms of the appearance of when certain fossils are found in the fossil record or in the geological column. And snakes kind of come in as they're kind of latecomers. That to me would not be an expectation. That would not be a prediction of flood geology, right? If there was snakes on the earth, and Genesis 3 records for us a snake, right? A snake in the Garden of Eden, right? So there are snakes around before the flood in the flood geology model. And yet, why did snakes not get preserved? Seems like they should be preserved. They're bony. Thus, many of them would be living in holes, right? And so in the onset of the flood, it's not like they're running to escape. Like the explanation some young earth creationists have for how some organisms escaped the flood early and why the remnants aren't found in the fossil record is that they were climbing up the mountains and jumping onto floating mats of vegetation and so forth, right? Trying to save themselves. And they did so for long enough that many sediments got laid underneath them before they finally succumbed and then became part of the fossil record. But could snakes really be able to slither away from a chaotic global flood that's coming on in full force? It seems like snakes should show up. If we have a lot of snakes in the Eocene, all right, some much later period, relatively large numbers of snake fossils are found, much higher in the fossil record. Many of them post-flood, so they're not hard to fossilize if they can be fossilized in any non-global flood situation. And yet there's a dearth of snakes in the fossil record. Okay, so that's point number one, just the observation of where snakes appear in the fossil record. All right, let's skip on down. Let's learn about this particular snake. Right, they're describing a new species of snake. They have very good preservation of this particular snake. So they have all the cranial anatomy. They've got the teeth. They've got the works, right? The vertebra and so forth. So they can describe the snake to great detail, which they do so in this paper. And so we have a description. This is actually the whole portion of the snake encased in the rock that was found in. Once again, showing like paleontological work is a long, slow process. This encased rock took many, many years in order for people to extract a portion, to be able to extract it to the point where you're seeing it here. Now, today, we have all kinds of fancy instruments that are able to peer through our bodies, right? Well, we can use those to peer into rocks as well and be able to produce 3D structures of what's inside of a rock. And so, therefore, we can see fossils. And that's one of the reasons why we have so many new fossil discoveries that are coming out at sort of a greater pace. It's not necessarily that there's that many more paleontologists out there. It's just that the tools have gotten so much better that we can extract the information from the rock so much more quickly now. All right, a bunch of description of the fossil itself. This is not really important. We don't need to talk about exactly what type of snake this is, where it fits in with other snakes and other kinds of snakes. It's clearly a snake, and it's clearly a very large snake. And here is their sort of diagram of the position the snake is in, all right, when it got preserved. It's actually wrapped itself up. It's actually coiled around one egg, which is crushed, although they're not sure that the snake actually caused the crushing of the egg. What's most notable, though, is there is the remains of a small sauropod. And this is not the remains of a sauropod that was inside of an egg. This is a sauropod that appears to have hatched. Maybe hatched very recently. It's still in the nest. Maybe just getting it's just getting used to being outside the egg, learning how to. The idea of these types of dinosaur nests for sauropods not necessarily theropods. It's thought that the behavior of many theropods is very different, kind of bird-like in the sense that they actually parent the eggs or incubate the eggs. There's actually dinosaurs that have been captured sitting on a nest, right, in the fossil record. Those are more the theropod dinosaurs. The sauropod dinosaurs, right, your four-legged, on the ground leg dinosaurs. They appear to have laid eggs in not so organized nests, sort of digging out an area, laying eggs, and then possibly putting some debris on top of them, or maybe sand. They create a nest and then they leave, and it's just up to the youngsters to figure out what to do. And that's what appears to be the case here with the sauropods. So consistent with a lot of other reptiles. And so this sauropod is just getting up, and it looks like this snake is right there in the nest. Now, I should also note that they found two other snakes also clearly associated with other nests in the area, but this is the snake that's the most complete. And besides, this particular nest actually has a sauropod in it, like a sauropod youngster, like in the nest. And so this was like the best representation. So this is one they worked on, and this is one that they're describing, but they're saying that we actually have other samples as well. So this appears to be a colony, all right, or a nesting site in which these are all the same species of dinosaur because they're all the same type of eggs. They found other juveniles at different stages in the sediments in this particular area. And so it's because really we were looking at multiple layers with some nests, like maybe some years the nests got buried very early in some kind of local event. Other times maybe the nest didn't get buried, and the eggs survive and they hatch. And then there's some event that actually kills a couple of youngsters and so forth. So you end up with an assemblage over probably multiple different seasons, breeding seasons, in which you have captured different sort of time slices of events that occurred in different seasons. So you have youngsters of different, juveniles of different ages. So here you have a snake that seems to be predating on the juveniles. Now they actually look at the cranial morphology and they determine that the snake probably could not open its jaws wide enough to be able to envelop the egg or to be able to grab an egg and actually break it. These eggs are very, very large. We're talking, some of the biggest eggs. These are Titanosaurus eggs, and so these are some of the largest eggs from dinosaurs. And these snakes do not have detachable jaws, or that can be determined by looking at the anatomy that they found in these snakes. And so these snakes seem to have, we'll call it more primitive characteristics of the skull, right? More reptile-like more like other things that aren't snakes, right? Rather than modern snakes. And so they seem to have some limited ability in terms of what they could swallow, the size of what they could swallow. But the Titanosaurus, hatchlings, right, were not too big, right? And so they determined that they could have been eaten by these snakes. And so that's probably what these snakes are doing, is they're predating on these particular things. Let's give you something else to look at while I'm talking about the second problem. All right. So the first one was just where snakes are found in the fossil record. It's not where I would predict they should be found with the hypothesis of a global flood in which all the geological columns laid down pretty much all at the same time. And so the second challenge, or really I'll combine the second and third challenge, because the second challenge is really the presence of dinosaurs and the ability to lay eggs, the nests themselves. Then you have the problem of juveniles in the nest, because that suggests incubation, which takes some period of time of the eggs, and hatching, such that you then have juveniles in the area where the nests are. And so all of that requires time. So this is very much like my last flood geology failure episode just a few days ago, in which we talked about insect borings, all right, beetles that have come to carcasses of dinosaurs and then have been eating on the bones and then laying their eggs in the bones, and then the pupa that hatch from those eggs actually bore into the bones even more. All of that takes a considerable amount of time, right? There's a certain life cycle that has to be gone through by those beetles. And so you have the challenge of how did the beetles find the dinosaur dead bodies in the middle of a flood? So why are the dead bodies lying on some surface? And then how did the beetles find them? And then how did they complete their life cycle, all during a flood in which supposedly they're all being laid down very quickly in the fossil record, right? This is kind of the same thing. This is just like a repeat story, just with a different fossil. And I'm trying to reiterate that these are not uncommon examples, really. This is the nature of the fossil record. This particular fossil illustrates and supports the observations I've made previously about preserved dinosaur nests. I've written about them a lot on my blog. All right. So if you went to my blog, naturalhistoria.com or naturalhistorian.com, either one, I've written about fossil cocoons in dinosaur eggs. I'm going to do a video on that one next. I've written about the complex ecology of dinosaurs and the flood hypothesis. I've talked about juvenile dinosaur fossils in nests, which I'm going to talk about a little bit more here. I've written about fossil eggs and nests and how pregnant dinosaurs are all stressed out, and that's why they're laying eggs, according to some young Earth creationists. So in a couple of these, I noted that dinosaur nests from Mongolia are found in multiple layers of rock sitting on top of, 20,000 feet, right? Layers of fossil bedding rock. So to explain this, how do young Earth creationists, how do flood geologists explain how this could happen? You get 20,000 feet of sediments laid down, and then on top of those, you have these dinosaur nests. They have to explain how dinosaurs could have been roaming around on the Earth's surface after all this prior sediment had been laid down in just a few days or possibly a few weeks. Then they claim that pregnant dinosaurs, right? I think this is Michael Ord, if I remember right, makes this argument that the stress of the flood, right? Because there would have been dinosaurs that were pregnant, right? They're ready to lay eggs, and then all of a sudden there's the oncoming flood, right? And they're running away, they're running to higher ground, or they're jumping on vegetation mats in order to sort of cling on for dear life. And so or treading water, right? They're just treading water for days or weeks. And then they're running out onto newly layered sediment deposits, because most young Earth creationists will admit that probably the entire world wasn't completely covered with water constantly during the time of the flood, but it's sloshing around in great tsunamis, right? And so there's higher land that's sometimes getting covered and washed over, and new sediments being laid on top, and then sort of it's uncovered, right? The water moves away, and then the water kind of comes back, and then it covers that region again. And so there would be like locations where there could be sediments in which animals could jump off and or could run up on shore, and they could be on land for some period of time before the next wave comes by. And this is where they think all the dinosaur footprints came from, and the other billions of other footprints of other organisms that are found in the fossil record in thousands of different layers of sediments. So this is one of their explanations for that, which we also have already talked about as another failure of flood geology. Anyway, back to our stressed pregnant dinosaurs. So this was a time supposedly when dinosaurs are so stressed out that they would have, as soon as they saw a patch of land, they'd be like, I gotta drop these eggs, right? I gotta get this nest. And so they just like scramble on shore and they push away some sand, and then they just drop a bunch of eggs in there. Voila, that's how you get dinosaur nests. Now, of course, to do this, you'd have to have hundreds of thousands, really, of dinosaurs doing this, because there are hundreds of thousands of dinosaur eggs in various layers. Right, so they're a common thing in the fossil record. Not as common as the bones or the footprints, but certainly there are many. There are many locations on Earth where there are literally thousands of dinosaur eggs that are preserved. And typically like one species, right? And so that's another thing. Somehow during this flood, it wasn't just that a few dinosaurs managed to survive and then managed to get on some little spit of sand and then lay a bunch of eggs there. They had to be a whole group of dinosaurs, like a whole group in this case of sauropods, very large sauropods, that all had to survive, and they all had to be together. And a bunch of them had to be pregnant at the same time, because they had to lay a whole bunch of eggs in this location. And so that's quite a lift in terms of, that stretches the imagination, thinking about like how that could happen. And then soon after laying these eggs, the nest and the eggs had to have been covered over again, by the next wave, right? So that they would get preserved in the fossil record in the geological column. Except that we've got lots of dinosaur nests that have broken eggshells, and it's clear that the eggs have hatched. Well, how have they have hatched? Right? They had to have been incubated, or they had to have gone through a period in which the actual dinosaur had to develop inside the egg prior to that. So we're talking about a couple weeks at least. And in the case of titanosaurs, we would expect that it would be it would take quite a bit of time. I don't know exactly what the estimate is in terms of the time for the development of a titanosaur, but they're relatively large organisms when they're coming out. We're not talking about little chicken eggs here. And even a chicken egg, takes a couple weeks in order to develop a chicken inside that egg ready to hatch. And then we have not just new hatchlings, right? We have juveniles that may be a couple weeks old that are preserved for us in the same type of locations. So all of this, once again, just like the insect boring thing, suggests the passage of time at a particular location that must have been relatively calm for all these things to have occurred. And now the cherry on the top again, in this particular case, is we're going to add one layer of complexity. And that layer of complexity is we have added some snakes, all right, to this situation. We have a predator, right? And there's multiple snakes of the same species, and they appear to be the right size of snake to be able to take advantage of these particular sauropods and these particular nests. And so now you have another, wow, that's quite a coincidence that these snakes managed to survive a flood that covered the entire world, laid down thousands of feet of sediment, and then these dinosaurs managed to find the same kind of dinosaur, the same species of dinosaurs, a whole bunch of them, managed to get here and lay thousands of eggs in hundreds of nests on multiple different layers of sediments. So suggesting they came back multiple times to the same spot after successive waves of new sediment were brought in by this sloshing of the water around the world. And on top of that, somehow these snakes, which appear to be well adapted to eating this particular type of animal, happen to also have been, I don't know, swimming around in the waters for a month, and then just so happened to find these particular dinosaur nests, and like, voila, look at that. I found my food right here, What a coincidence. Quite a coincidence. Now, as implausible as this scenario painted by young Earth creationists might sound, their hypothesis is just, I think this example, my prior example, and the next one I'm going to give of wasp cocoons, which are found inside of dinosaur eggs as well. Turns out Titanosaurus eggs again. They're painting a picture of half-crazed dinosaurs running around trying to escape the next wave, washing new layers of sediments all over the world, laying nests in barren sand layers, and then running off, trying to find higher ground again. And then we find this nest contradicts everything about that particular explanation, right? That's not the prediction of that particular hypothesis about how dinosaurs managed to leave their footprints in locations. How do they manage to leave the nests? Okay, we got the pregnant, stressed dinosaurs. That's how that's what's forcing them to lay these eggs. But now we find this clutch of preserved eggs, a hatchling dinosaur. So this is weeks later, right? After these eggs have been laid there, during a flood which is depositing thousands of feet of sediment, so hundreds of feet of sediment every day. Somehow it took a break for several weeks at this particular location. And we have the snakes there as well, right? So maybe young Earth creationists could suggest that some lone dinosaur survived for weeks of flooding and then laid its eggs, and there was a snake that survived on a vegetation mat that happened to be there at the same time. But are we really to believe that there is hundreds of the same species of dinosaur, all laying eggs, all in the same area, and then there was multiple individuals of the same species of snake that all ended up in the same location, all preserved that way? That's certainly not something that I would say is a prediction of young Earth creationism, of flood geology. How could these snakes survive for weeks, if not months, in a global flood that killed like every other animal except the animals on the ark? There are far more reasonable explanations for the preservation of dinosaur nests and eggs that don't include a global flood. After all, we have examples of preserved nests of many other animals from the last couple million years of the fossil record. And those are times in which young Earth creationists believe were after the flood, right? So those were all formed in local events, local catastrophes, windstorms that covered things up with sand, debris flows, all right? Many of these dinosaurs lived in regions. In fact, this region is described as a sort of a lowland area, which there clearly was higher land around it. This is a meandering stream bed area, which is semi-desert but tropical. So there's like probably a rainy season and then there's a dry season. Right? They're laying their eggs, the rainy season comes on, there's a monsoon, and many of the nests get covered with sediments. Other ones survive and more dinosaurs hatch, but many of them don't make it, just like lots of turtle eggs don't survive today. All right, but enough do to make another generation. Right? It's not difficult at all to see how dinosaur footprints, juvenile samples, that snakes could be preserved. All the things that we observe here are things that could get observed, that we could observe being fossilized or have an opportunity to be fossilized under present day conditions in different parts of the world. This is not what we'd expect from a global flood. So over and over and over again, I find that a close inspection of the evidence of specific fossils like this one show that the young Earth hypothesis is nothing more than an artificial construct with really no explanatory power. They like to talk about giant fossil bone beds and there's billions of fossils, and that's what we would expect to find if there was a giant flood that covered up the whole world. It's a very generic explanation, generic expectation. But when you dive in, you start looking at the actual fossils themselves and think about how to explain this particular fossil and its context and the sediment that's preserved in. Those generic hand-wavy explanations have no explanatory power. They don't really explain the actual details of the fossil record themselves. Yeah, that's it. That's my latest flood geology failure. A really cool snake fossil found in a natural position in a nest of eggs. I'll just throw in one other thing. You might wonder, could all this have just been kind of thrown together by the flood, right? You'd have eggs and you have a snake and you have a juvenile, and maybe they all got washed around. They're all just floating around. They're all dead. And then they just get sort of laid down in a location where all these just happen to be together, and we see that. I've already given you enough information to know that that's not a very reasonable explanation for this particular observation, because there are many, 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 many nests in this particular area. And the eggs are found in localized pockets. They're not randomly scattered around. There's lots of eggshells and other things because things get broken up, get stepped on and so forth, but there are discrete identified nest with typical numbers of eggs in them. And then you have snakes in multiple different places. And you also have eggs that aren't broken. A lot of eggs that are complete and whole, like completely preserved. And so that's probably not going to happen in a large flood. For one thing, they're not going to float. And so they're going to knock into things. How would they get preserved? By being moved from one location to another. So the chance that this would all get washed together, and also the juvenile its bones are all basically connected together. And so that's also not a situation where you just have random bones that are ending up there. They're sauropod bones. So all of that suggests that this is a natural position. This is a site that included these organisms in a real community, right? Living at a particular point in time. And that this really is a nest that we have preserved for us, a snapshot in time. All of that represents a very serious challenge to the idea of a catastrophic global flood as young Earth creationists envision it. All right, that's it for me. Thanks for hanging out. We'll talk to you later. Bye-bye.